Okay, so starting the recording, this is the July 17th meeting for Carpenter DRA Working Group. So we had already started talking a little bit, basically, about what we've been doing this past week. I guess to recap for myself, I'm starting to be able to spend some more time actually digging into the user stories for DRA and Carpenter. The main thing I'm looking at is the existing NVIDIA DRA driver and seeing basically using that as our getting started point for this is how users are actually going to be using DRA. What does Carpenter need to support to have a usable MVP? So my goal by the time we meet next week is to have those user stories ran up and we can go through them in this meeting.
Mhm.
I guess, do you want to recap what you were talking about?
Yeah, of course. So, um, Jack is out right now, but his main thing is to do the user story on our side. For me, I edited the RC scheduler notes because before it incorrectly had device capabilities as like a separate structure, like a matrix and dependencies like that. But I think all of that will be taken care of with node overlay. So I just updated all of that to take those mistakes away and replace it with node overlay. And then I also just wrote out some steps for that first step we talked about last time where Carpenter would just recognize that a pod is DRA enabled,
Mhm.
doesn't go ahead and create nodes. Um, yeah, we can go straight into that actually.
Yeah.
So to recap current behavior, Carpenter creates the nodes that can't satisfy, and those nodes obviously can't satisfy the DRA requirements, so the pods are left pending. So it just like doesn't know that the pod is DRA enabled. Um, I think for what I was thinking to do was just in the pod data struct, like add a flag. Um, and then in scheduler, we have update cached pod data. So that happens in,
Oh no. Do you want to share your screen if you're looking at like the doc?
oh sure, yeah. I don't know. I don't think I'm allowed to. When I click more, it doesn't have share.
Oh, interesting. Try now.
Oh wait, I'm sorry. I think I was looking at the wrong thing. Okay.
Yeah, as far as I can tell, you should be allowed to share. It looks like it's set to all participants. Okay, perfect.
Um, okay, cool. Um, yeah, so I wanted to add a flag in the pod data struct. Let me see. I don't know, maybe it's easier if I show it on the actual code.
Sure, go for it.
Oh yeah, here. I was just gonna do like a flag in here. And then this is all this would be saying is if this pod is DRA enabled. And then the value of that flag would be set in here in update cache pod data. So then I think here is where we would check like the actual spec and see if it has like the word resource claims in it. And then if it does, then we would set it to true. That was like what I was thinking.
Yeah,
Okay, yeah. And then
that's reasonable.
I was thinking, and then inside the add part, let's see. Yeah, we basically want to see like if the pod data has that flag set to true, then we want to exit immediately. I wanted it in here. Let me remember why I said that. Oh yeah, because obviously we don't want to schedule.
Yep.
So yeah, in here we would just check, and if not, it would exit and return. I was thinking to just make our own DRA error, and that's because like I was looking at this error.
Mhm.
This is its own error. Let me- Yeah, in here. So now I'll just make a new error that's like DRA enabled error.
Yeah, I mean, we may or may not need that. So I will say, like, I'll call out the reason reserved offering error we're kind of special casing is because there is some special scheduling behavior when a reserved offering error is bubbled back up.
Yes.
So
Yes. Yeah, yeah, yeah.
specific,
Like if it's like we don't want to relax preferences if that error exists. I think I remember that.
yeah, it's also when it bubbles up back to the provisioner or to disruption from the scheduler, we don't actually treat it as an error because kind of the intention of the reserved capacity or reserved offering error is that okay, there was no remaining reserved offering on this iteration of the scheduling loop, but we may be able to schedule it to a reserved offering on the next iteration. So we're just going to defer.
Okay.
So it's some pretty special behavior. I don't know if we need any special behavior for DRA errors at this point. Um, this is something we could also look at in a PR review. Um, I think we were talking a little bit about this before we started the recording, but yeah, this is something I think we can go ahead and do immediately. Like if you were interested in cutting a PR for this,
Mhm.
I'd be happy
Yeah.
to review it. Um, I think we can treat this as a bug in the current implementation rather than something that needs to be part of the DRA RFC.
Okay, that sounds good. So instead of, I mean, we can talk more about this on the PR itself, but maybe I just return and I don't return an error.
Yeah, I think the only reason you would potentially want to um, return like a special kind of error is if you wanted to indicate in the logs like this is specifically incompatible because of DRA. Um, like that could be a useful observability piece, but that would really be the only reason I see we would need to have a separate error type. So yeah, I think it's something we can look at in the PR. I could go either way on if it's necessary.
Yeah. Okay. Yeah, I would be happy to take a crack at this. Um yeah, that was my main thing. My other Oh, I did also have an extra question. So in this part, and we can kind of look at like schedule right now, we
Mhm.
calculate the daemon pod overhead for each template. And that's in, I think it's at the very beginning.
Yeah, it's when we're actually
Oh,
resolving all of the templates, then we go ahead and create a cache of all the daemon overheads.
oh, okay, so not here or this is what
Yeah,
I
no,
was,
that's it.
okay. Yeah, and the reason why we're doing that is because like there is a substantial amount of overhead where it would like impact the algorithm, right?
Yeah, so
The
basically
resource.
like the overhead in this case, when we say daemon set overhead, this is like the resource and yeah, the resource requests for all of the daemon sets. So like what this function does is based on the template, we figure out which daemon sets will be compatible with that template and figure out the resource requests. Because if we didn't consider those, we could potentially be oversubscribing
Mhm.
node claims during the rest of scheduling because those daemon sets are guaranteed to schedule or should be guaranteed to schedule. So if we didn't have this, potentially like there's a race and a pod schedules first and a daemon set isn't able to schedule, or not all of the pods are able to schedule.
Uh-huh. Okay, that makes sense. But then, is this the only case of a non-user pod where we need to calculate this overhead? Because I was thinking that maybe there's other overheads that we need to also account for.
Um,
Or is this just the
Potentially, this is the only thing for like vanilla Kubernetes.
oh,
I know you have other operators and such which have daemon set like constructs that don't actually use a daemon set under the hood. I think we have an open issue or two for being able to support those. I would consider that out of scope of DRA specifically, though.
okay, gotcha.
Um, yeah, that applies to just scheduling in general. Um, but yeah, for vanilla Kubernetes at least, like no other operators with their own daemon set like construct. Yeah, this is all we need to account for with regards to pod overhead. We also account for overhead from like system reserved and cube reserved. So two settings on the kubelet, but that's per instance type, and we account for that when um, like the instance type struct, and this is more relevant for DRA. The
Yeah.
instance type struct has like the set of resources that it can support, and we already account for that overhead in the instance type struct itself. So I don't think DRA, as far as I'm aware, there isn't any like new overhead concept associated with DRA. So I think everything that already exists is sufficient.
Okay, yeah. Yeah, I guess I was just asking in general for how schedule works
Yep.
by itself. But yes, perfect. Yeah, that was my last question. Um, yeah, I mean, I'll just um start. Oh, not here. I'll start this and then
Okay, perfect. I think
um,
I did want to, I know you said um, Jack was working on the user stories. I can't recall. I want to say he might have said previously one of the main use cases for Azure was supporting like the new, well, newish NVIDIA GB200 instances. Do you remember if that's the case?
I'm honestly I'm not really sure. I think like it sounds familiar, but I think just going straight to Jack for that
Got it.
is
Okay.
better. Do you need it for like this week or
No, I'm just curious because it's overlapping with some of our use cases, and I think so like previously we had discussed that you have an association, like you basically have this binding between resource slices and instances,
uh-huh.
which I think generally is the case. Um, so for the GB200, basically, like if you're not familiar, this is like one of NVIDIA's, uh, it's a rack of NVIDIA instances.
Mm.
Each individual like compute unit has two GPUs and a CPU. And then all of these are connected via a fabric. And
Mhm.
memory can be shared across all of the instances. And so that the way, and I may mess some things up here, I'm still kind of getting familiar with this myself. But the way that NVIDIA is reasoning about it for DRA is you basically create a resource slice for something called an IMAX channel, which is basically like, uh, I think you can, for the purposes of this, think of it as like an isolated set of memory. So any process that shares an IMAX channel can also share memory. So it's a way to like do
Mm.
memory isolation across all of these shared GPUs. And so
Yeah.
this IMAX channel is not necessarily associated with any given instance. So that is like kind of the one thing over the next week that I want to try and reconcile is how would we support these types of resource slices, which, while they're associated with instances, they're not necessarily associated with any particular given instance. So, like I said, I'm still learning about this. Unfortunately, given the cost of these instance types, I don't know if I'll be able to just get one to test with. Um,
I
but
never thought about that. Yeah.
but yeah, minimally, I'm working my way through reading the GPU driver that NVIDIA published for DRA.
Uh,
So yeah, I'm working my way through that, trying to understand exactly how that works. Like they have a construct that they built on top of DRA called compute domains. So you as an end user aren't actually dealing with the resource slices, resource claims, etc. yourself. You basically create this compute domain, it creates the resource claims, and then I think it also interacts with the NVIDIA driver to create the resource slices. Um,
but I thought this is where the node overlay comes in play, like that bridge between resource slices and instances.
well, that's where this one's a little bit different is so you have this IMX channel. This IMX channel is associated with a set of instances rather than a single instance. Now, maybe it's enough for us to know that if you create this instance type, you can create an IMX channel which which can be used across a span of instances. That
Hmm.
may end up being enough. So it might not really break down what we've already talked about, but that's something I want to try and work through
Yeah.
a little bit more this week and understand how it would actually interplay. Um, because there is still an association in that you need the instance to get the IMX channel. It's just that that IMX channel isn't associated with any specific instance. Like if
Mhm.
you had four of these instances from this GB200 like rack and you have an IMX channel, my understanding is it is no more associated with one instance than another instance. Like
Mm.
it's associated with all of them equally.
I see. Would this work? Like to me, this work would be uh, like inside node overlay though, right? Or would it just be like part of our work with DRA?
Well, the reason I don't know if it meshes directly is because node overlay gives you kind of a it gives you a way to say this particular instance type has these resources to publish. What it doesn't say is what we don't have a mechanism to get is like you need four of these instances to get one resource.
Mm, like a specific number, not the type.
Not necessarily a specific number, but just that like you need a group or that this resource is shared across a group of instances.
Okay, gotcha.
This may end up collapsing to being something relatively simple where we can just say like, yeah, any of these instances can create an IMX channel, but the IMX channel can be associated with any of the instances we create with some set of constraints, maybe. Um, but yeah, it's like I said, I've really only just started thinking about this, so I'm not coming here with an answer for how we solve this, just like this is
Talking about.
a problem we probably do need to solve to be able to support this use case.
Yeah. Okay.
And at least as far as I can tell, this is like kind of, at least for NVIDIA, was the main use case for DRA. It's the first thing that the DRA driver officially supports. Though it does look like in the next official release of the DRA driver, they're also planning on adding support for more conventional, like GPU workloads. And so that's where you get support for being able to do like time slicing and uh, GPU partitioning via DRA.
Mm-hmm. Gotcha.
So that seems a little bit more simple because you have still that one-to-one mapping between a resource slice and a node.
Mm-hmm.
But here, where it's this one-to-many mapping between a resource slice and nodes, that's where I think it might be a little bit trickier to make it work with the node overlay model.
Yeah.
So I still think the node overlay model is probably what we go with for the majority of use cases, but we might need something extra to support this other use case.
Uh-huh. Yeah. Makes sense.
And the reason I do think this is something we want to think about early is it could impact how we actually do the representation for DRA and memory. Like maybe we find out, you know what, associating a DR like resource slices with instance types really isn't the right way to model this. Um, I think it still will be, but I do think that this is something we should consider early on for the MVP implementation rather than punting it as like a follow-up, just because it could affect the underlying memory model that we use.
Is the main reason why like our our mental model of like the resource sliced instance type mapping could not work is because of time slicing, or like what's the main reasoning for why that won't work?
Well, I think with time slicing, the instance type to resource slice is fine. Uh,
Okay.
the main concern I have here is that you basically have one resource that maps to one resource which is associated with many instance types. Or I shouldn't say many instance types, one resource that is associated with a set of n instances. So, and that isn't something we have a way to directly model in Karpenter today.
Yeah,
Like
okay.
right now, you have an instance, that instance publishes its resources. It doesn't like it's completely exclusive from other instances. We don't have this concept of a resource which is shared across multiple instances. So, like, let's say you have a pod that has a resource claim request for one of these IMAX channels. How do
Mhm.
we know that pods could schedule to multiple instances and use the same IMAX channel?
I see.
So, yeah, this is kind of the main thing I'm probably going to be thinking about over the next week because every other use case I've looked into, I think fits into the model we've discussed pretty well. This is the one where it's just a little more uncertain to me.
Uh-huh. Could you repeat this point? I think I missed this. If the pod has a resource claim to an IMAX channel, because like you want to do it to a set of n instances with the shared memory.
Yeah, basically, so pod one, you have multiple pods with a resource claim for an IMAX channel. How
Mm,
do we know that they can land on different, distinct instances, but still share the same IMAX channel? Oh, it's IMEX, IMEX, not IMAX.
you like this?
Yep.
Okay, gotcha. Okay, yeah.
So,
Oh, there's some more here. Okay.
yeah. And like I said, some of the things I've said today could very well be incorrect. I'm still learning about this myself.
Uh-huh.
Um, So I'm far from an expert. I've been working my way reading through the source code for the DRA driver, and then also reading some of the documentation that's available. But given it's still like a work in progress, the documentation and such is on the limited side.
Hmm. Yeah. This is like, it's really interesting. Like, I never would have thought about some of these problems, but it's cool.
Mhm. Yeah, we just launched support for this instance type like a few days
Yeah.
ago, so it's top of mind for me.
Uh-huh.
Um, but yeah,
Hmm.
I think I looked and Azure's supported it for a couple of months now. So, and I do think I recall Jack mentioning that this is one of the main use cases you guys are looking at.
Hmm. Um, yeah, I can definitely ask him. Or he'll be back on Monday, I think. So,
Okay, perfect.
yeah.
But yeah, because I think everything else, the one interesting thing that I'm not sure how it works with like, and this is where I just need to learn more about how the driver works, is with something like, say, time slicing. The idea basically is you're multiplexing a single physical GPU to use like so multiple pods can have simultaneous access to a single GPU. I believe the way that this worked pre-DRA is you would configure, like you would basically say, okay, I want to expose 8 replicas of this GPU. So now instead of having like NVIDIA GPU 1 as a resource available on your instance, you would have NVIDIA GPU shared, and then you would have 8 of them. And so now you can have 8 pods that go to that. And yeah, once you have those 8 pods that go to it, nothing else can schedule. So you have basically a way of setting an upper bound of pods that schedule to a single GPU. I haven't been able to find how that works with, at least in the current DRA driver. And now, granted, the time slicing implementation like isn't enabled by default yet, so it's still a work in progress as far as I can tell. So maybe it'll be added. Um, that's one of the other things I think we need to answer because Carpenter will be happy to schedule 1,000 pods to a single GPU if you let it,
Hmm.
even if even if maybe like the cube scheduler, because it uses like the least allocated allocation strategy, would have round robins those pods essentially to a bunch of different nodes with GPUs.
Hmm.
Whereas Carpenter is going to try and bin pack it into as few nodes as possible. So I think one of the other things I want to understand for kind of that user story around partitionable GPU devices is how do we understand like what it upper bounds for how many pods can schedule to a single partitionable device? And this is simply, I think, a knowledge gap in me learning more about how like what mechanisms DRA has for this and how the driver works. Um, I don't think this is an unsolved problem. I think it's just something I need to learn more about.
Hmm.
It does look like I saw that there was an alpha feature called counter sets, which it looks like is basically the mechanism for this, but I don't see it implemented in the GPU driver yet, so I'm not totally sure. I think that that gets out most of the things I've been thinking about over the past week. Like I said, my goal by next week is to have some, and I'll add to this doc, but some a solid write-up for, at least from our side, what we think that the user stories look like and what a MVP implementation in Carpenter would need to look like to support those use cases.
Hmm.
And then I think, yeah, combined with the user stories from your guys' side, I think we can start driving to the splitting up the actual requirements and trying to scope out the actual work.
Yeah, that sounds good. Um, yeah. And for me, I'll just do the PR, the book PR.
Yeah, sounds good. Yeah, once you get that up, uh,
Yeah,
feel
I'll
free
ping
to ping me
you.
on Slack and I can take a look.
Hmm. Okay, sounds good.
Yeah, I think unless you have anything else, we can maybe call it early.
Um,
I'm free for the next 24 minutes, so I can stay on if we have anything else. But
I don't really have anything else. Maybe after the recording, we could keep meeting. I was just like curious about like your personal like journey about how you got into this.
no, sure. Okay. Yeah, if there's nothing else for the recording, then we can go ahead and stop this. All right.